Okay, so we've already talked about how a chemical might vaporize into the atmosphere from soils. Now we're going to talk about how it might move with soil water in the unsaturated zone. Okay, so most pollution does move through pores with water, and water flow is a function of a lot of the things we've already talked about. Height above sea level, so this is gravity or potential energy. Hydraulic conductivity, which is abbreviated K, and then pore water pressure, which we've talked a little bit about, and here we're going to talk more about. Okay, so here we're going to focus on hydraulic conductivity and pore water pressure, and in this video we're going to talk about hydraulic conductivity, and then we'll talk about pore water pressure in the next one, just to keep the videos a little bit shorter. So both K, or hydraulic conductivity, and pore water pressure change with the amount of water-filled pore space in the unsaturated zone. So here first we're going to talk about hydraulic conductivity. And water content, it's often abbreviated as theta, just by convention. It's the fraction of bulk soil containing water, and it ranges between 0 for a perfectly dry soil to taking up all of the pore space in a soil. So between 0 and N, essentially the value for porosity. And here you can just sort of see different water content. So this is saturated, all pores filled up. Field capacity is when water stops draining from the soil. So everything that's held there is sort of held there by capillary action, which we'll talk more about. Typically you're somewhere in between field capacity and wilting point. So wilting point is the point at which water is held so tightly next to soil particles that plants can't extract that water from the soil. So it's essentially dry as far as plants are concerned. Okay, so how would you expect hydraulic conductivity to change as soil water content decreases from saturated to wilting point? So you can pause and think about that for a moment. What might you expect it to do? Okay, well, it's a little bit complex, but in general, K increases as theta increases. So as pores fill with water, hydraulic conductivity increases. As soils dry, so as you move from a saturated soil to a dry soil, hydraulic conductivity decreases. So this is because you start getting little air pockets, roots of travel, water travel, chemical travel becomes windier because you have to stay in the water. The area of water flow decreases, drag forces increase because you're now closer to soil particles more frequently. So as soil pores empty, hydraulic conductivity decreases. Okay, and then in the next little video I'll talk about pore water pressure.